fs3128, this is topic 10 class 1, where we start on the last major topic for the course. We're talking about calculus, and calculus has got two broad halves. One of them is differentiation and the other is the reverse operation of differentiation, integration. So topic 10 is going to be a fairly brief look at differentiation. Differentiation, or differential calculus as sometimes it's called, is all about looking at how one variable changes if another changes. Now, we already know about slopes of lines. We already know about how y changes if x changes. So we kind of know that if we're looking at a graph. Now, a lot of people think that calculus is all about graphs. It's not. It is about how one variable, y, changes if x changes. It's just nice and convenient to draw it on a graph, but it's not all about graphs. But the discussion is made kind of more simple if we think about it in terms of what happens on a graph. If we've got a straight line, then the slope we know is the rise over the run. It's the change in the y over the change in the x. And for a straight line, the slope or the gradient is going to be constant. Now, moving on from that, if the line is not straight, then the slope is not going to be constant. So what we're going to be looking at is the idea of a non-constant rate of change. So if we're talking about this rate of change, or if we're talking about the gradient, then we're going to talk about the change in y for a given change in x. And the reason that we use d is that it's the Greek letter delta, and we use delta as a symbol for change. So dy by dx is simply the change in y for a given change in x. Not referring to page 408, but referring to page 435, if you've got the current edition. Now we're looking at a function that's not a constant function. It's not a straight line, so the change is going to be non-constant. What we can do is we can get an almost 100% accurate idea of the slope at a point by finding the slope of the tangent at each of these points and collecting all that information into what is called a gradient function. And then the function will give us the slope anywhere on that line, whether it's straight or not. Now, there are techniques to find the slope of a non-straight line, but in this course we're just going to take it as given. You will use a table of gradient functions to find the gradient or the slope of a line. But remember also, you are finding the rate of change. It's only the gradient if it's drawn as a graph. If it's talking about some relationship of how height changes as weight changes or something like that, and it's not drawn on a graph, we can still talk about it sensibly as being a rate of change. So we can use a table, and the table in your textbook is given on page 437. And all we have to do is find the appropriate format and look it up. So finding the derivative or the gradient function or differentiating x to the 4 means we need to find 1, 2, 3, the fourth line where we're looking at y equals x to the power of n. And if you look at that, the derivative is given as nx to the n minus 1. So using that, then the derivative is going to be n, which is 4, x to the power of 4 minus 1, which would be 3. So that is the gradient function, that's the rate of change function. Similarly here, it would be negative 2x. Now you're going to take away 1 from negative 2, so it would be negative 3. To find the derivative of cos 3x, we're going to look at the second to bottom one. So the derivative of cos 3x will be negative 3 sine 3x. to find the gradient function of e to the 5x, we're going to be looking at the 1, 2, 3, 4, fifth one from the top, and the derivative of e to the kx is k e to the kx, so it would be 5e to the 5x. To find the gradient function or the rate of change function for a natural log function, it's the bottom one on the page there. Now, it's slightly more than on the page there. What we've got is y equals natural log of kx. The derivative is going to be k over kx. So it would be, in this case, 3 over 3x, which is 1 over x. So just think of it in terms of this format, rather than just it's always being 1 over x, because later on when we do more complicated ones, it's not going to be 1 over x, it's going to be this idea of k over kx. The process then of finding the gradient function is called differentiation, and we are finding the derivative. So we're finding the slope function, we're finding the rate of change function. Once we've got that function, then we can find, if we've got a graph, we can find the gradient at any particular point. If we've just got some function that we haven't drawn of, we can find the rate of change at any particular point. Let's have a look at the example here. We've got a function y equals sine 3x, and you're asked to find the gradient where x is 0.4. A big thing here is that your calculator must be in radians when we're doing calculus. So if y equals sine 3x, then the derivative, the rate of change function, is going to be 3 cos 3x, just from our tables. And now if we're going to find it when x is 4, that would be, 0.4, would be 3 times cos of 3 times 0.4. So that would be 3 cos of 1.2. Look it up on your calculator and you get it to 4dp 1.0871. Look at the sorts of things that you can already calculate. Now we can find the derivatives of all of these, and some of them are really fancy functions. Some of them we need to rearrange slightly so that we, for example, number 21, we can write it as y equals x to the negative a half, and then we can differentiate it. So then the derivative becomes negative a half x, and then take away 1 to the negative 3 over 2. Our list only gives us the derivative of one function. Obviously things are going to be much more complicated than that, so we need to have a few rules that will deal with more than one function at a time. So for example, if we've got y equals 3x plus sine x, there we've got two functions in the same thing. So we need to use this rule 1 that says if y is made up of two functions, then the derivative is just going to be the derivative of those two functions added together. So the derivative of 3x is 3, and we're going to add to that the derivative of sine x, which is cos x. And the same works for subtraction, and the same works if we've got more than two functions as well. The second rule there says that if we've got, and we've already kind of done it, if we've got y equals 3x, then what the second rule says is that that's the derivative is equal to 3 times the derivative, in this case, of x. And the derivative of x, if we look it up on our list, is 1, so our answer is 3 times 1, which is 3. It means we've got the ability to do something more complicated like this, then we can say that the derivative is going to be 3 times the derivative of sine x. And we know that the derivative of sine x is cos x, so it would be 3 times cos x, or 3 cos x. There's some work for you to get onto. Exercise 33.2 and 33.3, and then my math lab, some rules for finding gradient functions.